Let me get hooked up here. All right. Yeah, I'm Mike Lynn. Work at Facebook on client platform engineering team. I go by a lot of other names as well. Frogger is the one that you'll find me at a lot of places at. It's actually my address at Facebook. You can also find me under Pudquick at GitHub and Mikey on Twitter. I don't feel bad for the history or the fact that I got all these different names. Just live with it. This talk is kind of related to some talks that I've done elsewhere before. Just this last year I did PyObjective-C the Frogger way at MacTech, which the video of it actually just went up, and Reverse Engineering the OS, a practical guide at Penn State Mac Admins in 2017. This one is an Osquery specific talk. Those ones are not, but if you are interested in what you see today and you want to go more in depth into using PyObjective-C in a lot of interesting ways, I'd really recommend checking out both of those talks available on YouTube. So, a lot of you are, if you're new to it, welcome. Osquery is fantastic. There's a ton of data there. Right now, I think if you go and look at the Osquery website, the total number of tables is at 200 or above?
207.
207, nice. So like crazy amount of data, right? And so in theory, like everything you could possibly be looking for could be under one of those tables, right? It's under multiple OSs too, Windows, Linux, macOS, and get new stuff added in all the time. But what if what you're looking for is not actually currently available in the Osquery project? So if something's missing, first thing I'd recommend you do is, like I said, there's a lot of tables. Go back and look. Maybe you haven't looked deep enough on there. Sometimes it may not be in a table that you would expect it to be in. Like for instance, for a while there on macOS, the preferences table that we had actually was really more of a plist table, and it only actually looked at the files, and so it didn't really quite read preferences correctly. There's actually a preferences table and a plist table separately, and there are various file path specific tables as well. Like, not all of them are just like, give me a list of things. Some of them basically work as arguments for other things. Like you join two tables together, like you select from users, and then now that you have a list of users, you can go get the Chrome extensions. Like they're additive. You actually have to use the tables together. So that functionality may be there, you just might not realize it. So I'd really recommend going back and looking through the list. Also, new features are being added all the time. Definitely stay up to date on the latest version of Osquery. One of the cool new ones that was just added was automatic table construction, which is a really cool new feature, and I'm really excited that that one ended up in Osquery. It lets you basically provide a configuration where you specify a SQL query, a SQLite database that's on disk somewhere. You specify the path, the location that Osquery can find it at, and then you give it table parameters saying, basically read the SQLite database and ingest it directly into Osquery and expose it as an Osquery table. And like for these key values, which may have really obscure weird names, reformat them to these really nice plain names. So data that Osquery is not directly collecting itself, but some other tool is collecting and putting into these SQLite tables suddenly becomes available automatically in Osquery if you just point Osquery in the right direction. That's really cool functionality, and new stuff like that's being added all the time. So I definitely recommend that you just stay on top of the Osquery updates and just keep checking. Additionally, you can actually extend Osquery in a couple different ways. There's the SDK, where you can actually write native plugins, and there's the extensions, and we'll go over that here shortly. And lastly, If you can't find it, I'd really recommend reaching out to the community and asking, either on GitHub or in Slack. A lot of people may just say, you know, I don't know, and that's the same thing to say, but others might just pop up and be like, oh yeah, no, I just did that the other day. You got to look under here or whatever. Or they might be able to, you can open a feature request on GitHub and say, you know, I'm really interested in doing X. Is this something that could be possible with Osquery? And the community will chime in and be like, yeah, well, yeah, this seems like a cool thing. I'll help you figure out how to do this. I was always taught in school that C is like the safe answer. So for this talk here, we're going to go with C about extending Osquery. So let's write an extension. So in this hypothetical example here, I'm talking about a fleet of machines where across the entire fleet, we've rolled out a command. We've rolled out this command called foo status. It doesn't ship with the OS. It's something that's unique to my environment, but it's something that I want to actually expose and be able to collect in OS query. It's not really meaningful to expect this to be something that's supported in the core, especially if it's an internal tool or something super unique to your environment. But that doesn't mean that you can't expose it to OS query yourself with one of these extensions. So in this hypothetical environment, it's a really simple binary command. It just literally, you'd run the command and it just turns enabled or it outputs disabled. So if you go looking at extending OS query, one of the things that you'll come across is the SDK, which is going to show you like all the C++ and all this stuff like that. And if you're doing macOS stuff and you look at the OS query code base on there, it's not just C++, it's Objective-C++. Probably a lot of people in this room didn't even realize that that was a thing. If you haven't done C++, it's a very demanding language, and it can be not terribly beginner-friendly. But an alternative option that's available is actually Python. Python is a very popular language these days. Large part of the Mac admin community, their tooling and open source products are all built around the Python language. It's very beginner-friendly. Some of the core foundations of the language itself is that it should be pleasant to look at, easy to read, and simple and straightforward. And so the Osquery actually makes available the Osquery Python module, which makes it pretty trivial and easy to write a brand new extension with just a little bit of extra Python glue in it. So we're going to take a look at what that looks like here. So the example one that's actually posted up on the GitHub repo is foobar table extension. This one I think is a grand total like 36 lines or something like that, and easily half of them are comments. The actual extension essentially extends a Osquery table plugin class. And in that class, there are basically 3 core methods that you need to define. So those methods are the name method, which is what Osquery will call to get the name. So like when you do select star from blah, that's the name. So you put a name there, return that. That's what the name of your table is going to be in Osquery when you load up your extension. Then there's the columns method, which the return value for that is basically a definition of the names of your columns and the data type that's contained within it. So it's just a list of names and types, basically. And then lastly, generate, which is the method that Osquery will call to generate the data. And the result that you return is basically a list of key value dictionaries, essentially, where each item in the list is a row in your table, and then each key is one of the columns in your table with the value for that particular column. So to go back to our hypothetical example here of this command, to turn this into an extension, the straightforward way to do that would be to, in Python, use the subprocess module. And then we would just rewrite the generate function here to basically use subprocess to directly call foo status and read the text that comes back to it. Now in this particular example, that includes a new line. If you want the new lines in your table results, cool, by all means leave it in, but just be aware of that when you're writing extensions like this, that you're going to have to, like the output that you define the key value as is fully represented, including new lines. So if you don't want them, take them out. And then, yeah, just return the result. Pretty straightforward. So I actually made a simulation foo fact command here. It's literally just a bash script that echoes the word enabled, just to show you how you can actually go through and test this. So using the Python that we had before on there, a subprocess where it calls this command and consumes the output of it. We actually then, I put that Python into foo fact extension here, said Osquery load this extension up, and then wrote select star from foo fact, and there you go. It's automatically, seriously, it's like, I don't know, 10 lines of Python probably take about 5 minutes to write if you've ever done any Python. So if you've got commands on your machine that Osquery is not currently exposing in part of the core or some community project already, if you can write a command line tool that can output the data that you're interested in getting into Osquery, I'd really recommend taking a look at the Python extension library on there. With just a little bit of extra work on there, it doesn't take a whole lot to actually get that data into Osquery so you can start collecting it on an automated fashion from across your fleet. But what if you don't have one of those cool command line tools that actually has some piece of data that you're interested in? What if the data that you're interested in is something that's part of the operating system, but like, I'm going to focus on macOS here. Part of the operating system, but like Apple didn't actually provide you a command line tool for it. What if it's something that the user can see it, like they can click on a menu bar icon, or they can click on a preference pane or something, somewhere visually in the UI, that fact is trivially and easily available for an end user that's physically sitting at a machine, but you as a systems administrator or security engineer or something like that have no command line tool made available by the maker of the operating system to expose that fact so that you can wrap around that and then consume it into Osquery, or a publicly documented API that you could just write some native code and tap into that and pull those same facts. What if that's the situation you find yourself in? So the answer that I have for you on there is we need to first file an enhancement, radar with Apple, and then wait, and maybe wait a little bit more. And while you're waiting, you're probably going to want to try and go and figure out how to do this yourself. You might be waiting for a long time. So that's what I'd like to show you how to do today. So before we can even start your hunt for how to get these details out of the operating system, you have to know how to hunt in the first place. Your search terms need to be something like, we're going to go hunting through the operating system for where is this data located at. When I mentioned earlier, like menu bar items or preference panes and things like that, the data that you're looking for is usually text. Hopefully it's not a graphic, because I don't have any recommendations for you on there. But if it's text that you're looking for, cool. That's like something that we can actually search through the entire computer for. So you're going to want to look at the display that's made available to the end user and hopefully find some very unique text that when you go searching for it, the hits that you get back are going to be specifically related to code or tools or something like that that is responsible for making that text appear on the screen. So like an example of that, like I've got 2 theoretical examples here, like I have no banana facts versus I have 10 banana facts. So if you had I have no banana facts, that is a static string. It is not going to vary from user to user or device configuration to device configuration. There's no substitutions that are being done by the code and injecting some dynamic piece of data. It is a static string. These are the #1 thing you really want to look for. If you only have something that's dynamically generated, hopefully either at the beginning of the string or at the end of the string or somewhere in between, you have some static piece in that dynamic string that does not vary. Like in the I have 10 banana facts example, you just look for banana facts, which is hopefully unique enough to get you in the right location. The problem with dynamic strings is that the way that they're built by the operating system, it's done with variable substitution or string format strings, that the source template string that is used to generate this dynamic string, you don't know what that looks like, and all the tools that you're going to use to go searching through the operating system, you wouldn't know what to type looking for that. So pick a part that doesn't change, because that's what we're going to go hunting for. So some of my favorite tools to go hunting with include ripgrep and the Silver Searcher, or AG. Both of these guys, like if you've used grep to go searching through your machine on there, it can be actually pretty slow. these guys have insane, literally metrics and charts if you go to their websites. Open source free tools, super great. If you've got homebrew installed on your machine, you literally type like brew install ripgrep or AG or the Silver Searcher on there. These guys, I can search an entire macOS operating system install in under 60 seconds flat for a string. And it searches through binary files, like we're talking gigs of data, and it's super, super fast. Definitely highly recommend those tools. Also, it helps if you're looking in the right place. Apple's core executable code on their macOS is generally hosted within either the system or the /user or /applications folder or some subfolder within. And additionally, if you're looking for stuff in a particular type of UI, those component pieces are located in very specific folders as well. So like all the like menu bar items that ship with the operating system, those are all located under System Library Core Services menu items. Preference panes located under System Library Preference panes. As you use these tools, ripgrep and Silver Searcher and stuff like that, you may get hits back that are .string files. These ones are sprinkled all over the place, and they are actually XML. And the same tool, PLUtil, which is meant for property lists,plists, can print the contents of it and let you inspect those a little bit deeper. But like Apple has these very specific Apple-specific structures and folders that as you start doing these searches, you'll be like, okay, it's one of those. So like the strings, for instance, you'll do a search, you'll get a hit in a string, and if you get a hit in a string in this, it's probably because Apple is doing their really excellent job of localization. The string that you're looking for is probably maybe the English version or whatever your normal language is of that string, and the code doesn't actually have the English version of that string embedded in it. The localized version of it is over here in one of these string files, and you'll run plutil or plutil against that string file, and it'll say it's just a big key value list. You'll have the English value, and the name of the key is your next stage in the hunt, because the name of the key will be constant across all the languages, across all the string files. So when you go searching for the name of the key instead of the English version of the string, that'll take you closer to the code, which is what you're looking for. Again, keep track of the results as you're doing these searches. You're going to get a lot of hits across a lot of different locations. You're generally, if you picked well with your unique strings, you're probably going to end up in the right neighborhood. So if you look and you see it's under a particular sub folder of an app, you're like, okay, this is about the space that I need to be looking at. The strings one that I mentioned on there, like the key values that come back. Apple, like you may see the text displayed in the UI. Apple internally, whoever the developer was that wrote the code, they have an internal concept of what this part of the code is called, a nickname for it basically, and you'll see those nicknames become common. So like you look at the name of the key and it'll start with like prefs system blah blah blah. Start looking for those prefixes like pref system, and you'll find like all related code for that particular thing on there. Objective-C, which is still the biggest chunk of the language that the operating system is written in, encourages extremely verbose descriptive names, which actually really helps us when we try to go hunting for these things, because everybody has a choice when it comes to writing code about what they want to name a new method or a class or anything like that. Apple follows a very descriptive pattern. So generally the names explain exactly what this particular thing does, which is totally to our benefit. So keep an eye on that. There's other tools that come in the operating system that can help you with your hunt as well. The FS usage tool, if you're not familiar with it, will do a streaming list of file system operations that are happening on your machine while you're continuing to do what you want. So if you've got a UI that you click on it and it shows something, run FS usage in the background while you click on it and reveal it, and you'll see these hits to all these files that are being loaded or accessed when that piece of data gets displayed on the string, which will give you an indicator of either a path where that's where your data lives, or a path that might be referenced in code that calculates the data for where you live. So don't just go hunting within the code directly, but try and actually like reveal or show or interact with the UI while you're monitoring what the computer is doing in the background, and that can help reveal where this stuff lives. So once you run ripgrep or AG and you've targeted it all the way down to the executable, the next thing in order to basically make the operating system interoperate better with our monitoring tools is that we're going to need to start pulling apart that code. So we're going to start talking about a disassembler at this point. So in the spirit of free and open source tools about the talks here, Radar 2 is actually a very popular disassembler that's out and freely available right now. I would love to be specifying just this guy on here about this talk today, but the feature that I want to show is unfortunately in a paid product, which is called Hopper. But the cool thing about Hopper is anyone can immediately try it. It has actually essentially unlimited free trials. They're time-based. The app will quit, but you can reopen it again and just continue where you left off. So it's honestly not that expensive. I'd recommend checking it out. That's kind of what my talk's going to be focused about. So let's actually run through a demo of doing this. So in this particular demo, we're talking here about the App Store Preferences pane. App Store Preferences pane has all these cool check marks about how an operating system is currently configured to deal with automatic system updates. Do I download stuff in the background? Do I automatically install things? Like there's a whole set of preferences on here, and they can be checked in any number of combinations on here. And additionally, if you've got a profile installed, stuff may be managed or grayed out that you can't actually affect, the end user can't actually click on this stuff. But the problem with this particular preference setup on here, you would think that, okay, it's just a set of preferences. There's a preferences table that's in Osquery. I should just be able to use FS usage, find where the preferences live, and boom, we're done. We can just read the preferences out. It turns out in practice, there's a little black magic that's going on in this App Store preference pane. The out-of-the-box configuration for Osquery is actually not really good at being able to pull these particular details. There's some internal implementation details from this that we need to go peek under the hood basically and see if we can actually figure out what Apple's doing or take advantage of what they're doing. So using the AG tool, Silver Searcher here, I ran a search for download newly available updates in the background, which is one of the text items you can see on there on the checkmark. And I got a hit, appstorepref.nib. .nib is, again, one of these Apple-specific things. It's an interface file, which is kind of sucky that that's the first hit that you get because interface files have no code in them whatsoever. They are purely a layout UI thing. So if you get that hit, it's kind of like, bummer, I didn't get code on the first try. But that's okay because the code has to reference the interface file. So we found the interface file, appstorepref.nib. Now we're going to go search for appstorepref and see where we get hits for that. Bingo, we get a hit. We get the binary file, App Store Pref pane. I mean, we kind of could have guessed that it would have ended up there because we were looking at the App Store Pref pane and this is the executable for that. But I just wanted to show that like the Silver Searcher thing found the reference to that string within the binary, and it's super fast when you do this. Both Silver Searcher and ripgrep are automatically recursive. If you don't know where any of this lives, you can literally search at the root of the hard drive, and like I said, it'll be done in like 60 seconds flat. So now that we found the executable, let's pop it into Hopper and we'll actually take a look at what Apple's doing under the hood. So we open up the App Store Preference pane and we type in appstorepref, that nib file, into our search. And because we start out looking for strings. Strings are what we were searching for, so we're going to click on strings in Hopper up here, the middle section on the columns there, and say, show me all the strings called appstorepref. Show me the code that references this as a string. And we get a hit right away at the top. So we click on it. And looking at a string, it's just a string. It's just a piece of text that's somewhere in the code. But the cool thing is you can go up to the navigate menu and say, show me references to this string, which will then go show you the code that talks about and uses this particular string. So we click on that, and it shows us that there's a Objective-C class called the App Store Pref class. Cool, we're going to click on that guy. Well, actually what we're going to do is we're going to search for the App Store Pref class. So we go back to search, and this time we click on labels and type in App Store Pref, and right off the bat there we get App Store Pref init with bundle. If you look at the Objective-C design and how classes are done, init is the bootstrap of any particular class. So this guy references the nib file, the UI, and this is the initialization vector for it, like the first piece of code that gets run when the App Store Pref pane is opened up. So we click on that to actually go look at the code responsible for loading this nib file and showing this text to the end user. So if you do that, and this is why I wanted to show Hopper specifically, the code is written, when you compile something, it goes down to assembly at this point. Assembly sucks to look at. I mean, this is a particularly bad section. It's just initialization. It's really, really, really boring assembly to look at. But one of the cool features of Hopper is that it has a pseudocode mode where it can take the assembly and actually attempt to reverse engineer and back out what the original Objective-C might have looked like that generated that particular assembly, and it does a pretty darn good job of it. So we click on the little pseudocode icon in the corner here, and it takes the assembly, and poof, suddenly we've got something that actually looks like code that we can actually check out and go, holy cow, we can actually see what this thing's doing. And right down here, we see this thing called SU Shared Pref Manager that it's spinning up, and this code actually basically, it makes one of these little guys and then reads all the settings out of it. It can call a method for every single setting that's in there. And if you actually go and take a peek at this guy, there is some black box stuff in this initialization stuff. There's some undocumented paths for the App Store prefs updates and stuff like that that are all listed inside here. But it doesn't matter because we know what Apple is calling code-wise to look up should this checkmark box be on or off. It makes a SU shared prefs object, and then it, like, you can see is check scheduled. There's like a list of about, I don't know, 15 or 20 of those, one for every single checkmark box, and we can just check every single one of them. So we found it. We found what controls the state of those checkmark boxes. Where's the code? So now we're gonna go, where's this SU shared prefs guy? We're gonna go back one more time to labels and look them up. Uh-oh. We got Objective-C class. That means that it's not actually in the App Store code itself, it's external to it. So we're gonna click on that, and it'll actually show us where that guy lives. He lives in a framework. He lives in a private framework. That's one that Apple won't document for you. That's one that's an internal usage only, but we can use it. And that's the best part, is that if you find a result that lives in a private framework, you're on the right path here because you can call the code just like Apple did with their preference pane, only you can write your own tool for it now. So here's how we use it. So we go back to the example I gave before where we did subprocess. Subprocess was all geared around calling a command line tool and wrapping around the output of that. We're gonna gut all of that. And instead we're gonna come back with PyObjective-C. PyObjective-C lets you bridge Objective-C language from Python. It actually ships with the Apple operating system. It's built in. So in order to take advantage of it, you want to make sure that your extension is running with the native Python that ships with your OS, or you're going to have to ship PyObjective-C in some way that's available on whatever Python you're shipping to the OS. And so you end up, the main trick that I'd love to point everyone towards is NSBundle. NSBundle literally has the ability to say, load code from this path. And you could just point it straight at the private framework and say, gimme the thing. And it'll load up the private framework, and then you can simply go from that private framework, give me the class name SU shared pref. I want to play with that bad boy. And it'll actually give you an instance of the SU shared pref. So if you go back and look at the code, they said shared prefs, shared pref manager, that's usually an initialization. It's a singleton pattern where there's a code that you call that gives you access to the instance of that particular class. So we're going to do the same thing. SU shared pref manager. Give me the guy. Give me the guy who knows the facts. And then we can literally pull those exact same facts that the preference pane did, going line by line for all the things that they do that are checkmark box. We can go and call those exact same things. Does background download? It's just a method on the class, and we get back a true or a false, and that's our checkmark box. So we can actually use the class dump tool and aim that at this framework, and it'll give us a list of all the API, the entire API for this undocumented class, and just gather all the exact same data that Apple's locked away in this non-command line tool, and then expose it to Osquery via this Objective-C calls, PyObjective-C calls, and now we can collect data that before there's no command line tool for, no API for, nothing documented for it. This is the type of thing that you probably want to do after you've filed that radar, so that you can then come back to Apple afterwards and prove your case, like data wins arguments, right? Like go forward, don't be blocked, don't wait on Apple for this to do it. See if you can figure it out for yourself, and then come back to them and say, see, I got all this derived value out of this, and I need you to do this in an official way, because as much as fun as I enjoy doing this kind of thing, as much as I'm trying to show other people about how to do this kind of thing, the world is totally yours when you're doing this thing, but Not everything is available. Apple has some design patterns in their operating system where they're purposefully segmenting things with XPC, where they're making a user interface with a very controlled little narrow window of API to go talk to the back end. And if you're not coming through the right front end, like it's not signed by Apple or it's not it has a particular entitlement or something like that, the Apple will actually deny it the access to it. Not everything is like that, but more and more I've seen the operating system kind of head that direction. We lucked out in this instance in that we found a private framework that we could just load and directly instance. Some code that has been really interesting, like the MDM stuff and all that kind of stuff these days, is it's a background daemon, and all the logic is internal to the daemon. There's nothing to link against and run code and look stuff up, unfortunately. And like I said, long term, ask Apple for an official way to do this. This is like a totally unofficial way to do this, and it's an internal implementation detail, and Apple can change that right out from underneath you. They'll do it within an operating system. So it's cool you figured it out, but the next point release comes out and suddenly all your data breaks or stuff like that. And yeah, subject to change anytime. But even serious, hopefully this is interesting to you, and I just recommend, don't feel like you are limited by what ships Osquery. You can add almost anything to it. Just go forth and explore. Thank you.